Today we'll start a new topic, polynomials. And this polynomial and corresponding problems are important for B.Sc honors and as well as IIT joint entrance examination. So first we need to recall the definition of polynomials. So what should be the definition of polynomial? Polynomial is সংজ্ঞা কি? Now an expression of the form a0 x to the power n plus a1 x to the power n minus 1 plus a n minus 1 x plus an, where a0 a1 dot dot n all are either real number or complex number, and n is non-negative integer. That means n belongs to n union 0, the set of whole numbers, and x is a variable. Is called a polynomial of degree n if a0 is basically non-zero. So this expression is called a polynomial. Now there is one important note. If px be a polynomial, px belongs to zx, be a polynomial of degree n, where polynomial px equals to a0 plus a1x plus dot dot an x to the power n, then a0 non-zero and a0 a1 an all are basically integers. So similarly, if px equals to summation ai xi, I equals to 0 to n, that belongs to Rx. This is a real polynomial. What is the meaning of the polynomial? That means all ai are basically real number for all I equals to 0, 1, 2 up to n. And if I say degree of polynomial px, this is equals to n, that implies n must be non-zero, and this is also a real number. So as for example, if we take different example, আমরা বিভিন্ন example এখানে নিতে পারি. Say px equals to a0 plus a1x. This is belongs to zx. This is a linear polynomial. Now if px equals to ax plus b, that is rx, this is also a linear polynomial. So based on the degree of the polynomial, we can say the names of different polynomial. As for example, say degree, say we have taken the polynomial px equals to say an x to the power n, an minus 1 x to the power n minus 1 plus a1x plus a0, where ai are either real number or complex number for all I equals to 0, 1 to n, and n is non-zero. So in that case, this is important to recall. In that case, degree of the polynomial px, sometimes a d of px, degree of px, this is equals to n. Based on the values of n, say n equals to 0, that means px equals to a0, that belongs to either real or complex. This is basically called the constant polynomial. Constant polynomial. এটাকে আমরা constant polynomial বলবো. If n equals to 1, the polynomial px equals to a0 plus a1x, where a1 is non-zero, and this is basically linear polynomial. That means polynomial of degree n equals to 1, degree 1. Similarly, if we take n equals to 2, polynomial px is a0 plus a1x plus a2x square, where a2 are non-zero. That implies it is a quadratic polynomial. That means polynomial of degree 2. If n equals to 3, px is a0 plus a1x plus a2x square a3x cube, where a3 not equals to 0. This is a cubic polynomial. And if n equals to 4, so px equals to a0 plus a1x plus a2x square a3x cube plus a4x to the power 4. This is biquadratic polynomial. So based on the degree, we have different name of the polynomial: constant polynomial, linear polynomial, quadratic, cubic, biquadratic, and so on. Now the question is about the leading term of the polynomial. Leading term of the polynomial. What exactly mean by this leading term? Px equals to anx to the power n, an minus 1x to the power n minus 1, a1x plus a0, where all ai's are either real number or complex number for all I equals to 0, 1 to n, and n not equals to 0. So for that polynomial, the leading term is anx to the power. This term is basically the highest degree term, is called the leading term. So now we come to important points. Next, recall two polynomial of same degree. When the degree of two polynomial are same, if px equals to a0 plus a1x plus anx to the power n, and qx is another polynomial b0 plus b1x bm x to the power m. So these two polynomial, then degree of px equals to degree of qx if n equals to m and n non-zero and bm is non-zero. Now we'll think about one important theorem. That theorem is called division algorithm theorem. So division algorithm for polynomial, division algorithm. So division algorithm for integers, we know here we have to memorize the division algorithm for polynomial. Let fx and gx be two polynomials of degree n and m respectively, n and m respectively, and n is greater than equals to m. That means degree of fx, this is greater than equals to degree of gx. So that means fx, degree of fx is greater than gx, so we can divide fx by gx, and in that case we'll get a quotient. This is considered as rx, and a remainder quotient qx, and remainder is rx. So what will be the relation? The relation will be here fx equals to gx into qx plus rx, where either rx equals to 0 or degree of rx, this is less than degree of gx. That is basically called the division algorithm. So then there exists to uniquely determine, that means the quotient and remainder both are unique, to uniquely determined polynomials. One is quotient and other is remainder, qx and rx, satisfying fx equals to gx into qx plus rx. What is rx? Where rx is either 0 or degree of rx, this is strictly less than degree of gx. So this algorithm is called the division algorithm. So now we come to other important theorem. This is called remainder theorem. Next important theorem, this is theorem 1, division algorithm for polynomial. Now the remainder theorem. So remainder theorem is basically help us to find the remainder of a polynomial when it is divided by some linear polynomial. So if a polynomial fx is divided by x minus alpha, Then the question is, what is the remainder? Then the remainder, Bhagshesh, remainder is equals to F alpha. So this is the simplest theorem here, through which we can find out the remainder of a polynomial when it is divided by x minus alpha. So that means here if we apply the division algorithm, so fx is divided by x minus alpha, we'll get qx and rx here, and degree of rx is basically less than the degree of x minus alpha, or rx equals to 0. So that means here we can write fx equals to x minus alpha, some multiple of qx plus rx. Now the question is, what is rx? So this we can get by the division algorithm. So just you put x equals to alpha on both sides. So what will get? F alpha equals to, so alpha minus alpha, so 0 into q alpha plus r alpha. So just we think about the remainder as r. So just you consider this is the remainder. So just here you will see the remainder r equals the simple logic. How to find out the remainder when a polynomial is divided by x minus alpha. So here is one important note. So in that case, fx can be expressed as f of x equals to x minus alpha into qx, and here we get the remainder is basically f alpha. So we can write here f alpha. Now here one important definition that we can introduce. This is called 0 of a polynomial. 0 of a polynomial. So now the thing is, if f alpha is 0, then alpha is called the 0 of a polynomial, because on that case x minus alpha is a factor. So the definition is, if fx is a polynomial and f of alpha, some value f of alpha equals to 0, then alpha is called a 0 of a polynomial. So as for example, you have given fx equals to x minus 2023, and here we see that this is a polynomial and f of 2023 equals to 0. That implies x equals to 2023 is a 0 of polynomial x minus 2023. So in that way we can find out the zeros of a polynomial. Because আমরা 0 of a polynomial find out করতে পারি. So note, to define a set ZF. What is ZF? ZF means all those alpha belongs to real number such that f alpha equals to 0. What is f? Where fx is a polynomial of degree n, then this set ZF is called the set of all zeros of the polynomial fx. Okay, so this is very, very important. Now, next important theorem, this is theorem number 3. If fx is a polynomial and x minus alpha is a factor of fx, then we can say f alpha equals to 0. That means fx is divisible by x minus alpha, the remainder is 0. And converse is also true. Converse is also true. As for example, you have given x square minus 2x plus 1. This is your polynomial. And you see, since f of 1 equals to 0, that means if and only if x minus 1 is a factor of fx. So now we come to the different problem which is asked. This theorem is called factor theorem. So we have done 3 important theorems here without proof. The first one is the division algorithm for polynomial, remainder theorem, and zeros and the factors theorem. So now the question, we will do some important problem, how to find out the remainder of a polynomial when it is divided by a linear polynomial. So as for example, the question is to find the remainder. Find the remainder of x to the power 5 plus 5 to the power 4 plus x cube plus 5x square plus 2x plus 11 is divided by 2x plus 1. This problem is given in exercise 4 B.Sc Mapa book. And the problem is 1 when it is divided by x plus 5. Now what exactly is said in remainder theorem? In remainder theorem, if it is divided by x minus alpha, then the remainder is f alpha. Just you see here. So now we come to the problem and its solution. Solution here. What is our fx? Our fx equals to x to the power 5 plus 5x to the power 4 plus x cube plus 5x square plus 2x plus 1. Now we can write x plus 5 as x minus alpha, x minus of minus 5. So what is our alpha? Here alpha equals to minus 5, because if we represent as x minus alpha, so alpha will be minus 5. So what will be the remainder? So by remainder theorem, the remainder of fx, when it is divided by x plus 5 is equals to remainder r equals to f of minus 5. So that means minus 5 whole to the power 5, 5 minus 5 whole to the power 4, minus 5 whole cube, 5 minus 5 whole square, plus 2 into minus 5 plus 11. So what will be the value? The value will be 1. So here remainder is 1. So this is our answer. Similarly, you have given exercise homework. This is 1, 2. The exercise is 2x to the power 5 plus x to the power 4 plus 2x cube plus x square plus 4x plus 3. So you will find the remainder of this polynomial is divided by 2x plus 1. So in that case, what you will do? So you will write 2x plus 1 as 2 into x plus half. So this is hence. So 2 into x minus of minus. So here the remainder will be f of minus, because hence here alpha equals to minus. So this is your exercise. Now we move another important problem here. Next, problem 2. So prove that x square plus x plus 1 is a factor of x to the power 10 plus x to the power 5 plus 1. Now the question is, when you have given the fx or gx is a factor of fx, when you will prove that gx is a polynomial, fx is a polynomial, and gx is a factor of fx, so you will write gx as a product of linear polynomial. After that, you will check x equals to alpha 1 and x equals to alpha 2. They are the roots of fx or not. This is your algorithm you need to follow by factor theorem. So now here gx is basically x square plus x plus 1. So we have x square, we can write this as a linear factor x plus 1, that is x minus omega into x minus omega. What is omega? Where omega is an imaginary cube root of unity. That means that is omega cube equals to 1. So here alpha 1 and alpha 2 means omega and omega square. We'll check omega is a root of x to the power 10 plus to the power 5 plus 1 or not, and omega square will root হবে কিনা আমাকে চেক করতে হবে. So we just take let fx equals to x to the power 10 plus x to the power 5 plus 1. And now what is f omega? Just put the value of omega here and check it is 0 or not. So this is omega 10 plus omega 5 plus 1, and that we can write omega cube whole cube into omega plus omega cube into omega square plus 1. This is omega plus omega square plus 1, since omega cube equals to 1, as omega is the imaginary cube of unity. And if omega is the imaginary cube root of unity, in that case omega cube 1 and 1 plus omega square equals to 0. So that means this value is 0. Here if omega is 0, so by factor theorem x minus omega is a factor of fx. That means x to the power 10 plus x to the power 5 plus 1. Similarly, we will calculate f omega square and f omega square. So that means omega to the power 20 plus omega 10 plus 1. Just you put the value of omega square in this polynomial. So that will be omega cube whole to the power 6 into omega square plus omega cube whole cube into omega plus 1. So since omega cube equals to 1, so that means it will be omega square plus omega plus. And again this value is basically since 1 plus omega square equals to 0. So that means f of omega square equals to 0, and hence we can say x minus omega square is a factor of x to the power 10 plus x to the power 5 plus 1. So we have two distinct factors. One is x minus omega, that we can represent 1, and here 2. So from 1 and 2, we can say x minus omega multiple x minus omega square is a factor of x to the power 10 plus x to the power 5 plus 1. So what exactly this? That means x square plus x plus 1 is a factor of x to the power 10 plus x to the power 5 plus 1. So this is proved. Done. So these are two important problems here. And now we come to another concept, that is 0 of order R. So we already know 0 of a polynomial. So if we take two polynomial px equals to x and qx equals to x square, in both cases we see that p of 0 equals to 0 and q of 0 is also 0. That means x equals to 0 is a 0 of both px and the polynomial qx. So what is the difference here? So here you see the power. So if we put x square, x equals to 0 and x square equals to 0 means 0 is a double root. So that means here x equals to 0, it is 0 of order 2. It is a simple 0. 0 of order 2, that means double 0. So as for example, if we take x square minus 2x plus 1, that polynomial px, here you put p of 1 equals to 0. But we can write it as x minus 1 whole square. So 1 is a 0, but 2 times. So here we can talk about 0 of a polynomial of order R. 0 of a polynomial of order R. So here you will see x equals to 0 of a 0 is a x equals to 0 is 0 of x square, but order 2 x equals to 0 is a 0 of order 2. Here x equals to 0, that is also 0 of px of order 1. px of order 1. 0 of a polynomial, that means say px equals to px is a polynomial and alpha is a 0. So that means p of alpha equals to 0. But how many times order r? That means alpha is a 0 r times. That means x minus alpha whole to the power r is a factor. So here the definition is alpha is a 0 of order r of the polynomial px if x minus alpha whole to the power r is a factor of px, while x minus alpha whole to the power r plus 1 is not a factor of px. So for good understanding, আর একটু যদি ভালো করে বুঝতে চাই তাহলে we can represent with respect to derivative. Polynomial is a nice function. Polynomial is continuous as well as a differential. So we can differentiate the polynomial as many times as desired. যত খুশি polynomialকে differentiate করতে পারো. You can find out p dash x, p double dash x, p triple dash x, no problem. So there is one important theorem. If alpha is a 0 of polynomial 0 of order r of the polynomial px, if and only if p alpha, p dash alpha, p double dash alpha, p r minus alpha, this is equals to 0, r minus 1 times derivative, and then you will put the value of alpha. But pr times derivative at the point alpha is 1. So proof is basically self-in exercise. You will prove it. But the question is how, why? But we'll verify with the help of example. As for example, we'll take the polynomial px equals to x minus 1 whole square. Now what will be the p dash x? That will be 2 into x minus 1. And what will be p double dash x? This is basically 2. What we see? We see that p of 1, this is 0. P dash 1, this is also 0. But p double dash 1 is 2. This is non-zero. That means x equals to 1 is a 0 of order 2 of the polynomial x minus 1. In similar way, if there is a 0 of a polynomial, then we can say what should be the order of the 0. So here note, if alpha is a simple 0 means 1 times, simple 0 of the polynomial fx, if and only if, not 1, if and only if f of alpha 0, but f dash alpha is not. Similarly, alpha is a double 0 or 0 of order 2 of the polynomial fx. What exactly mean? If and only if alpha equals to 0, if dash alpha equals to 0, but if double dash alpha is not 0. So alpha is a 0 of order 3 of the polynomial px or fx if and only if alpha equals to 0, if dash alpha equals to 0, if double dash alpha equals to 0, but if triple dash alpha is not 0. Okay, so that we need to recall. Now we come to important problem. So next question, question number 2, question number 3. This problem is very important. Different examination where polynomial as a syllabus, and it is also important in Calcutta University B.Sc course. Question is x cube plus 3px plus q has a factor of the form x minus alpha whole square. Show that দেখাও যে q square plus 4p cube this is equals to 0. So now we come to the solution. What is given? The given is x cube plus 3px plus q has a factor of the form x minus alpha. Alpha is basically the double root. That implies alpha is a double root of fx equals to x cube plus 3px plus q. Okay, so here we consider let fx equals to x cube plus 3px plus q. What is the meaning of the double root? If alpha equals to 0, if dash alpha equals to 0, but if double dash alpha is not. So now, what is if alpha equals to 0? That means alpha cube plus 3p alpha plus q equals to 0. This is 1. And if double dash alpha equals to 0, that implies it is if double dash x. What is if dash x? If dash x is 3x square plus 3p. So that means 3 alpha square plus 3p equals to 0. Okay, and here we will see that implies p equals to minus alpha square. So this is 2. So therefore, from 1, alpha cube plus 3, p means minus alpha square into alpha plus q equals to 0. And here the value of q is 2 alpha q. Okay. So this is 3. Now we need to prove this result. Q square plus 4p cube equals to 0. Okay. Now, if you have given alpha square one side and alpha cube, and try to equal these two terms. Alpha square is not equal to alpha cube, but how it will be equal? You just think about the trick. You will take cube here and square here. That will be equal. Now you will put the alpha square from 2. So So what is alpha square? This is minus p whole cube. And what is alpha cube? Alpha cube here q by 2. That whole square. Okay. So we have taken this alpha value alpha square and we put this here. Since alpha square equals to minus p and alpha cube equals to q by 2. So what should be the result? P cube equals to q square by 4. So P cube equals to q square by 4. That means 4p cube minus p cube. So minus p cube. So 4p cube plus q square. This is equal to 0. So this is proved. Similarly, we come to another important problem. 4 is also very, very important. If x to the power 4 plus px square plus qx plus r equals to 0, here you can write by 2 and 3. Sorry, this has a factor of the form x minus alpha whole cube. Then show that 8p cube plus 27 q square equals to 0 and p square plus 12r, this is equals to 0. So now we come to the solution. So previous problem, here we will also take fx. This is our fx. So fx is the polynomial which is given of degree 4, qx plus r. And what is given? Given that polynomial x to the power 4 px square qx plus r has a factor of the form x minus alpha whole cube. So that means alpha is a 0 of order 3 of fx equals, because x minus alpha into x minus alpha 3 times factor. So x to the power 4 plus px square plus qx plus r. So that means here f alpha equals to 0, f dash alpha equals to 0, f double dash alpha equals to 0, but f triple dash is non-zero. So now we come to first thing, f alpha equals to 0. That implies alpha to the power 4 plus p alpha square plus q alpha plus r equals to 0. If double dash alpha equals to 0, that implies, we just think about f dash x polynomial, we can differentiate it. So 4x cube 2px plus q. So that means 4 alpha cube plus 2p alpha plus q equals to 0. F double dash alpha equals to 0. So what is f double dash x? This is 12x square plus 2p. So 12 alpha square plus 2p equals to 0. Okay. So what we'll get? We get here, therefore, alpha cube plus p alpha square plus q alpha plus r equals to 0. We get 4 alpha cube plus 2p alpha plus q equals to 0. and 12 alpha square plus 2p equals to. So now we'll do the back calculation. We'll start from last. শেষ থেকে শুরু করব and we'll go to the first. So here what is p? Here p equals to minus 6 alpha square. I put the value of p here. So what will be the value of q? So q will be minus 4 alpha cube minus 2p alpha. P means 6 alpha square. So that means minus 4 alpha cube plus 12 alpha cube. So that means here 8 alpha cube. We put the value of q and p here. So what will be the value of r? R is alpha cube minus p alpha square. So what is p? Minus 6 alpha square minus q alpha. What is the value of q? 8 alpha cube. That means minus alpha cube plus 6 alpha cube and minus 8 alpha cube. So that means 9 minus, so minus 3 alpha to the power 4. So this is alpha 4, not alpha cube. Alpha 4, alpha 4, alpha 4, 3 alpha 4. So what we get? We get p equals to minus 6 alpha square, q equals to 8 alpha cube, and r equals to minus 3 alpha. So in question number, what we have to show? We have to show the first and the second result. So here I just write it here. We have to show 8p cube plus 27q square equals to 0 and p square plus 12r equals to. So this is related p and r, here p and q. So p and r, we come to this one. So now we'll think about the trick. So here you will see alpha square and here alpha to the power. So write alpha square equals to alpha to the power 4. Is it equal? No. So you just take the square in that side. This is 1, this is 2, and this is 3. 1 and 3. So put the value alpha square from 1. That is minus p by 6 is whole square. So this is by 1. Alpha to the power 4 minus r by 3. So this is and by 3. So what is the result? P square plus 12r equals to 0. So this is shown. Done. And the other part, again. Now you will see p and q are related. So p and q is here. The first two. Here alpha square, alpha cube. So you will write alpha square, alpha. This is not equal. So what you will do? You will put cube here and you will put alpha square. So alpha square, that means p by 6 whole cube. Alpha cube here, q by 8. Q by 8 whole square. So this is by 1 and 2. So what we will get? We get 8p cube plus 27q square equals to 0. So this is another answer. Thank you so much and subscribe my channel.